So on tonight's homework 7.1, students learned today that when we are adding or subtracting fractions, if we have a common unit, and in this case it's going to be denominators that are the same, that the strategy for addition and subtraction is just the same as it would be for whole numbers. So for instance, if I look down here at number 2 and I see 3/5 subtract 2/5, I only really need to think about 3 subtract 2, and the reason is because I'm thinking about units, and in this case fifths. So the only mathematical operation I need to do is 3 subtract 2, which leaves me with 1, and because I'm dealing with the same unit of fifths, my answer is also going to be in the form of a fifth. So the key to subtracting fractions is making sure you have the common unit, in this case a common denominator. If we do, we're thinking about subtracting as we would with whole numbers, or thinking about a tape diagram. If I have 3 parts out of 5 shaded, and I take away 2 of those parts, how many parts remain shaded? 1 part out of 5. So students are going to be able to do 1 and 2 quite easily. When they get down to 3, this is where we start seeing improper fractions. Improper fractions mean that we have more parts than make a whole. And then in that case, what we get is we get an answer that's greater than 1 whole. This is what we would call an improper fraction, where we see the numerator is larger than the denominator, and a mixed number is where we see that mixture of whole numbers, which is the 1 whole, and fraction parts. So we're going to use the same strategy that you used in 1 and 2. If we have like units, we can simply subtract the parts in the numerator. So for instance, on B, if I do 7 subtract 6, I'm left with 11. The unit that I'm subtracting each time is eighths, so my answer is going to remain in eighths. And then what the students have been taught to do is create a number bond. A number bond is a way to break apart the number into 2 parts that give you the total. In this case, we always want to remember that our parts are always going to share the same unit, eighths. And to be able to see the mixed number, to be able to see how many whole we have to ask ourselves, how many eighths make 1 whole? Well, 8 eighths make 1 whole. Anytime we have the same number of parts as in the whole, we're equivalent to 1. And then here we see 11 subtract 8 means there's 3 eighths left. So these 2 smaller bonds should add up to the larger bond, 11 eighths. So what the student then thinks about is 8 eighths is the same as 1 whole, and then we just combine that whole number with the remaining fraction. So 8 eighths is the same as 1, and then my remaining fraction part is 3 eighths. So students are going to solve the same way they did in 2, and then once they have their answer, they're going to take it, break it into number bonds, and then create a mixed number where they have a whole, which is a traditional whole number, 1, 2, 3, 4, 5, and then the remaining fractional part. Students should be able to use these 2 parts that were done in 3 to help solve the remaining. On the back, we go from subtraction to the idea of addition. Same rule applies. If their unit is shared between the 2 fractions, we combine the parts that we have. So if you look at 4 and 5, we can see that we have the same units, in this case fifths, in this case is 11ths, in this case tenths. Because the units are the same, our answer is going to remain in that unit, and then we just combine the parts that we have to make our combined fraction. When you get down to 6, what it's asking you to do is use number bonds to decompose the sum, same way we did with subtraction. So let's look at D together. So if we look at D, we know that we're using the unit tenths, so our answer will be in tenths. Think about just 8 plus 5, those are the parts we have. We have 8 parts plus 5 more parts, we're up to 13 parts. The number bond is going to work the same way. We're going to take out what's equivalent to 1 whole. What's equivalent to 1 whole if we're thinking about our unit of tenths? Well, it would be 10. And then the next question is, what's remaining? If we had 13, we removed 10, we're left with 3. So this fraction becomes 1 whole and 3 tenths. Because this is equivalent to 1, this would remain 3 tenths. When you get to 7, it says use a number line to model your answer. We practiced this in class as well. So students would just simply draw a number line on their paper and label 0, and 1. In the case of the ninths, we wouldn't really have an equivalent half fraction because it's an odd number. What we can do is think about 9 parts to this number line. So students know that there are 0 ninths is here, 9 ninths is equivalent to 1 whole, and then the number line works the same way as a traditional number line with whole numbers. We're increasing by 1 unit each time. So in this case, our unit is ninths. So we'd go from 1 ninths, 2 ninths, 3 ninths, 4 ninths, 5 ninths, 6 ninths, 7 ninths, 8 ninths. What your student wants to show on the number line is that they want to show the movement from the first fraction backwards. And in this case, we're greater than 1 whole. 10 ninths, 11 ninths. Because we can see here this is an improper fraction. So we'd start at 11 ninths, and the student is going to subtract 5 ninths. So remember, that's 1 unit here. 1 ninth, 2 ninths, 3 ninths, 4 ninths, 5 ninths. Should bring us to 6 ninths. So this is the number model that they're going to show, number line to show the model of 11 subtract 5 is 6 ninths. So they show where they started, subtracting the 5 and ending at the next fraction. Same would be true for the next one, but remember, because these fractions are already, this one here is already greater than 1, your student may want to make their number line between 1 and 2. So thinking about this as 12 twelfths, thinking about doubling that, here you'd have 24 twelfths to be equal to 2 whole.